Hey everyone, and welcome back to FTC Crash Course Programming. Today's episode is going to be going over Java basics, and so this is meant for people who have never programmed in Java before, or even if you have, this will get you a lot more comprehensive overview of what you'll be using in FTC to program. And just a warning, this episode is probably going to be a bit on the long side. I promise that later on in the series, as we continue on, these videos are not going to be as long as these first two ones in the series are. It's just because these first two ones cover so much information, especially this one, so just be prepared for that. Alright, so today's outline, we're going to be going over what is Java and how do we use it in FTC for those who just completely don't know what Java is or just brand new to it. I know when I first started in FTC, I had no idea what Java was, and it was really kind of confusing to get started and everything. And then we're going to jump into Java by talking about variables and typing, and then we're going to be talking about some basic syntax that you have to know, and then we're going to be going over operators, methods, controls, stuff like if statements and loops. And then I'm going to introduce object-oriented programming. This is something that definitely you're probably not going to be able to fully grasp just from this first lesson, but I do want to get it introduced and kind of tell you some more advanced stuff so that you'll be able to mull this over. And then for homework, I'm going to have you be playing around with Java yourself in an online IDE just to get more familiar, and there will be a challenge project that's up to you if you want to complete or not. Alright, so first off, we're going to be talking about what is Java. So Java is a programming language, which means that it allows for humans to instruct computers to do things in a relatively readable and easy to understand and use manner. So what happens is that when you write your code, a compiler takes all this code that you've written and turns it into machine code, which is just ones and zeros, so that the computer can understand what you've written so that it can then be ran on a processor. And so many different programming languages exist, and they differ in their features and their syntax. And syntax can be kind of thought of as the words and structure that a given compiler will be able to understand. You can't just go writing whatever you want and expect the computer to know what to do. You have to do it in a certain way so that the compiler knows how to turn this into code that an actual CPU can run. And Java itself has had a lot of updates over the years, but in FTC, you're probably going to be using Java 8 or Java 7, and you're probably not even going to be using most of the new features that these things brought, so you don't have to worry about that as much. So first off, we're going to be talking about variables and primitive types. So a variable is simply a way to store information, and you're probably familiar with this in math, like when you use x in math equations to stand in for a number. So the thing here is that variables are mutable. You can change the value of a variable throughout the course of your program, and this is very useful for keeping track of things that change. However, there's also a thing where you can make a variable constant, then this is going to hold a constant number, so this is useful for things like something that's never going to change, like the width of your robot or the port that you plug something into. So in Java, all variables are strictly typed. So this means that you must say what kind of data you're storing in a variable as it's being created, and you can't put something else in the variable. One kind of data type is a primitive type. This is very simple and is implicitly created with a literal. So this is like an actual digit you type in, or a letter or something like that. Some examples here are an integer, so something just like the number 1, these are whole numbers, positive, negative, doesn't matter. A double, which just stands for double precision, floating point number, and so really what this means is that this number is going to be holding non-whole numbers, so fractional numbers with a decimal component. It's called a double because of the way it's stored on your computer and how computers deal with decimal places. And there's also characters, char, that's what you'd be typing in, and this holds just a single character. But it could also be things like a new space character or something like that, or a space. And then there's also a boolean, which is a true or false value. And there are the primitive types. These are the ones you're mainly going to be seeing. There's also a very useful type, string, which is used for a string of text, so double quotes. It's technically not a primitive type just because of how it's stored. It's actually like a custom object that Java gives you anyway, but just know that with string you get like a lot of built-in features that you can use with a string variable. And so the syntax for creating a variable is you put the type, the name equals a value. So for example, if you want to make an integer variable called myVariable, instead of equal to 1, you would do int myVariable equals 1, semicolon. In Java, a semicolon is kind of like the end of a sentence, right? So it's kind of like a period when you're writing English. A semicolon tells the compiler where a line of code stops, and so it knows this is the end of a line of code, so it knows to stop and move on to the next line. And that way things don't blend together. So now we're going to move into actually showing you a bit of this. Just a quick intro here. I'm actually going to be using an online IDE for this project called repl.it. It's completely free. You don't have to make an account to use it. The one drawback is that it's a bit slow, but it's very accessible, very easy for you to start working with Java in, and I recommend you use this just because even if last time like you did your homework, you installed Android Studio or you got set up with OnBot, you aren't going to really be able to do these kind of abstract things in Java and those very easily, so I recommend using something like this. So first off, we're going to like this here. You don't have to worry about this other stuff. I'll explain it later. Just know that inside this thing here, this public static void main, this is the main method. This is what's going to run your code when you run it in this IDE and Java in general. But you're probably not going to see this in robot code, and I'll talk about that probably in a later episode. So we're going to start here. I'm going to declare some variables. So for example, like I said, you put the type, you put the name. So I'm going to make a double, and let's say that I want to be storing the X position of my robot on the field. So I'll call it X position. Just a little other note here. I might have mentioned this or not, I'm not really sure. But in Java, you name variables with camel case. And so this means is that you start off lowercase, and then for every new word, you just make a capital, no spaces. You shouldn't put underscores, even though that would be valid. You want to follow the Java standard for naming things so that your code is readable and very easy to use. So for example, we'll start with double X position and make it 1.0. So there we go, we've declared our first variable. Let's say we also wanted to do a Boolean, we'll call it reached tape, okay, and then we'll make that false. Yep. So you can kind of see here, and I'll do one more for string, because we'll be working with strings a lot with things like telemetry, which is talking to the driver station to get feedback. So we'll call it string message, and we'll make this equal to literal string here of this is a message. So there you go. So that's declaring variables. Okay, so back to slideshow. Operators. So in Java, there are a lot of operators that allows you to do things with these variables or literals. Of course, it'd be very dull if you just were able to create these things and just kind of be stuck with the stored value. You can't do anything with it. It'd make your programs pretty pointless. And so there are a lot of operators. I'm not going to go through all of them because a lot of them aren't going to make any sense for FTC or even for most applications you're going to be seeing as you work in Java. Just start here. The first one is the member operator. This one I'm going to have to explain a bit later. You use the member operator to access a member of an object. Of course, it's going to make no sense right now, but just kind of the thing you do. Object.member. I kind of like to do a little preface here. So say for a motor, you give a motor variable and you want to set the power, you would do motor.setPower, which is a method, and you kind of can do that. And then you have your arithmetic operators. You do basic math with these, multiplication, subtraction, addition, and division. Pretty straightforward. Standard symbols you would see. There's kind of the example here. If you typed in 1 plus 2 in a place where you're going to display text, it would evaluate to 3, as long as you're keeping that as integers. And this is going to follow the order operations, PEMDAS, so you don't have to worry about that. You can add parentheses, things like that. And so here's a pretty crucial one, the assignment operator. This is not the same as equal to. You saw this in the last section about variables, is that when you create a new variable or you're going to want to reassign a variable, you use the equal sign. So that's saying, all right, take this value stored in this variable. When we get to control here, if you were to use this to say, is this equal to this, it will not work and it'll make your code do something really weird. Moving on, we have the comparison operator. So here's what you want to do if you want to actually compare values. This makes the most sense for numbers, so doubles or integers, something like that. You see the double equal sign is equal to. You can do greater than, less than, greater than or equal to, less than or equal to, pretty straightforward. And do keep in mind is that if you're going to be comparing objects that aren't literals or aren't of those primitive data types, things can get a bit weird. I know for strings you want to use the dot equals method, and I'll kind of explain that a bit later as I do some examples with this. But just know that these operators are going to be most useful with the things they're comparing being these primitive data types. And then there's logic here. These are obviously used with two Boolean things. Now, the powerful thing about Java is that you don't have to just type in true or false. You can actually type in a statement that will evaluate to true or false. And so the and here, if you're not familiar with any kind of Boolean logic, and means that both conditions have to be true. So this is a binary operator, meaning that it has two things that it's working with, same with comparison. And then the two vertical lines is or. You can find that if you do shift and it's the backslash right above enter on your keyboard. That's how you find that button. And so yeah, or will evaluate to true if either of the things you're comparing, either of the conditions you put in are true. All right, and then increment and decrement. This is kind of a shorthand. So yeah, with variables, there's kind of a shorthand with the assignment operator. Say if you want to add something to a variable, once again, makes no sense with numbers. What you can do is, instead of doing variable equals variable plus 1, there's a shorthand for that. You do variable plus equals 1. So it kind of just makes things a lot easier. I'll do some examples with that. And so really what we're doing here with the increment and decrement things, it's a further shorthand for this. When you do a variable plus plus, it'll increase by 1. Mainly you're going to be using this on integers or doubles, and then minus minus, it'll decrease by 1. So that's just a shorthand, and it's pretty useful to know when we get into loops. One more here is the not. This has to do with Boolean again. It basically flips a Boolean value from true to false or false to true. And this helps to do if what you're getting from a sensor is going to be giving you true, but you want to operate on when this is not true, something like that. So keep that in mind. It's an exclamation mark. So yeah, really practice will make these more familiar to you. I'm going to be doing a bit with operators here. So since we haven't gotten to control yet, I'm going to hold off on a few, but let's get started with that. All right, so once again, don't worry about this too much. You're not going to be using this probably ever in your FTC code, but don't worry about that. But to print out to the console, you can call system.out.println, print line, and you put something in there, and it'll print it out to the console as you can view it. Pretty useful. So we're going to start out with the arithmetic operators, just to kind of give you an idea here. 1 plus 2. Make sure to put your semicolon. See, we got 3, so that's pretty cool. Of course, we can do 1 plus 2 times 4, and this should evaluate first by whether order operations, which you get 9, not 12. So let's hope we get that. 9. Okay, cool. Once again, the assignment operator, pretty straightforward. I showed that already. When you make a new variable, you're going to do my variable equals, that equal sign is assigning the value to the right of it, variable to the left, 8.0. So yeah, comparison, actually can't show comparison, just on an if statement. So let's, for example, just gonna give it a here. Of course, true is a Boolean literal, so you can just type true, it works. So true and false, this will be false because both conditions have to be true. So here, false, right. Of course, true and true will give you true. So I'm not gonna go through all these, just kind of giving you an idea. Yeah, true. So false, once again. Or, this would be true, because or is, if either one is true, it'll be true. Oh yeah, also a comparison, I forget about that. So what we'll do is 7 equal to 9. Of course it's not, so we get false. It's false. All right, and then lastly, I'm gonna show off the increment operator. So you see here, I'm gonna make a variable, I'm making an integer, we're gonna call it just test, I don't know. And we're gonna make it 1. And then here, we're going to increment test by test plus plus. And so we're expecting it to now be 2. We're going to print out the variable test. And we should be getting 2. And operators do have a hierarchy of precedence. So some operators will be called before other ones. Generally, don't have to worry about this. Just know for the arithmetic ones, false PEMDAS. So really don't have to worry about that. All right, methods. As you begin writing code, you're going to realize that there are certain things you keep having to repeat in your code. Methods helps fix this issue and overall make your code look a lot more readable and makes it much easier to work with. So not having to copy paste a bunch of code makes everything really cluttered and confusing. And so methods begin with a method signature that follows this template. You put your access modifier. Do not worry about this right now. If you don't know what to do, you can just make it public. It's not the best practice, but I'll probably talk about this when I go into some examples. Then you put the return type. Some methods can return something. This is nice if you're doing like some math function. You want to return a number back, like it does something and returns something back to you. You can do that here. Or you can make it nothing. You can return any type as well as void. And void means that this method does not return anything. This makes sense for something that where there's something being output by the code, especially in robotics. You see this a lot because you're probably going to be driving a robot. There's something really relevant to return from that. So you'll be returning void. And then you put the name of the method, pretty standard. If you want to follow that Campbell case naming convention I mentioned, and then you can put parameters. So if you want to input something to the method to work with, you put the type of the parameter and then a parameter name. Of course, this seems a bit confusing now, but I'll be showing you some examples. And here's an example, it makes it a lot more clear. A public void drive forward for and then double time. Presumably inside your code then, you can use this variable time, which you'll pass in when you call the method. I'll show you how to call methods as well. This method could then be used to put code in there that would drive your robot forward for a certain amount of time and then stop it. And then you can just reuse that every time you want to do this. Your code becomes a lot more readable and less confusing. And the body of the method, so the code that'll actually be ran when you call it, is enclosed in brackets after the signature. I'll show you what that looks like. Make sure to follow proper indentation. So let's go over to that. Okay, so we're back in our code here, and you'll probably notice that this here is a method. Of course, we're not calling it. This is built into Java. It's the method that's ran in an executable program by the computer, by the compiler, whatever. So just don't worry about that. So I'm gonna make my own code down here, and that's pretty cool, because what I can do is say I want to make a function that add 1, right? Of course, you have something that does this already. Actually, it's something a bit more interesting. Multiply by 3. So actually, let's call it triple. That makes more sense. So triple, I'm gonna make this be a double, so you can put it in fractional numbers. So double, and I'll call this num. You want to make sure that your parameters have good names, really all variables, so that you know what you're working with. Because if you just use x for everything, or x, y, it's gonna get really confusing, especially if you have to come back to your code after like a break. It's really confusing to work with that. So we'll start here with triple, and then we're going to return. So if you want to return a value, type in return num times 3. So this is kind of a nice combination of what we learned so far. You see here we have the multiplication operator. And so we go up here, and once again, I'm going to be printing something out. Let's worry about this. You'll probably notice this is calling a method called print, and inside this, we're going to call a method called triple, and we're going to put a parameter of 3. So we're hoping we get 9. So we're going to run this. Oh, right, my mistake. I actually forgot to put a return type. So we have that. Oh yeah, and so this is a bit of a specific thing because this the main method is a static method. It's static here. Don't worry about that at all. So we get 9.0, which is good. All right, as you saw, you beat the bracket. You want to put a new line and then type your code in there, and that's kind of the general formatting for bracketed stuff in Java. All right, control. So you now should have a good arsenal of tools to write just individual lines of code in Java now. But your programs would be quite boring and pretty useless if they couldn't respond to changes or data that they get, especially in robotics. You're gonna want to be responding to external variables such as sensor readings or even just time. And so this is where things like if statements and loops come into play. So an if statement will execute code in its body if the condition you specify is true. And so usually you'll be using some conditional and Boolean operators and comparison operators to craft this condition, and it must evaluate to a Boolean value, of course, to be true or false. So you'll have an if, and then parentheses, and then your code will be in brackets like a method. Of course, you'll want to press enter. While loop will execute its code over and over again while the condition you specify is true. So basically this is an if statement that keeps checking over and over and over again forever until it's not true anymore. And so it's pretty similar, it's just while and your condition. And then lastly, we have a for loop. This is a bit more complicated, and it's going to be useful if you're working with lists or you want to do stuff a certain amount of time. And pretty much it's just a while loop that's optimized for progressing through a list or doing, like I said. The setup for this is you put for, and then those parentheses, and there's 3 things you want to put in. You want to declare a new variable. So like you talked about, you put the type, the name, and you want to assign it. And then you want to put a condition that it will check for, and if this condition is false, it will stop the for loop. And then the last thing you want to put in is a line of code to be ran after each loop. And usually this is going to be increasing a variable or decreasing a variable. And so, for example, here, if I were to run this loop for int I equals 0, I is less than 10, I plus plus, and then inside the body I print out the variable I would get the number 0 to 9. And you kind of see how that happens. All right, so we're back here, and I'm going to be showing off some control stuff. So I'm going to be setting some arbitrary variables up here. Of course, these will be handled by the actual FTC SDK, and you'll get real values from the robot. So say, for example, here I'll make Boolean reached tape is true, and I will make my motor something like this. I'm sure motor encoder counts equals 1,000. If you're not familiar with motor encoders, it's 2 things that are attached to the axle of a motor and that read how many times they do revolutions. So let's do some control. So say if I'm writing autonomous, of course it's not going to look like this. This is just kind of an abstract example. I'm just going to make it more relevant to FTC. Say if I want to do if reached tape. So the cool thing about if statements is that you don't have to do equals true. You can, as long as your overall statement evaluates to a Boolean, that's what it'll work, as I mentioned before. So that's good. So once again, just because I'm working with the main method, static, kind of annoying, but whatever. All right, so if reach tape, I want to we can print line, and we'll say we've reached the tape. So you'll notice here, oh yeah, also with if statements, I forgot about this, else, or else if. So I could have else if, this is a different statement. If this is false and then this is true, it'll run this, but I'm just gonna have an else here. So if this is false, the reach tape, it'll run this instead. And so let's copy this over. We're not at the tape. All right, and so let's hope that when we run this, we get a message that says we've reached the tape. And we do. And now it's cool, you'll see here, written false, we're not at the tape. So you can kind of see how this applies. While loops are a bit more tricky for me to demonstrate here just because I'm not getting active change. If I did a while loop regarding this would never change. Maybe I could do something, so I could say while reached. Actually, that's not a good idea. So this is kind of like a for loop. Just ignore this. While motor encoder counts. See, I'll use a comparison here is greater than 900. We're going to decrement it. So you see here, like the risky thing is that I could wind up in an infinite loop if I never change the variable. I'm kind of stuck in a loop forever. This is very bad. It's going to type your phone, and your code is probably going to crash after a few seconds of getting stuck in an infinite loop. And then here, so you'll see this will run, and just for fun, I'll print out motor encoder counts. And then, so generally, you're not going to want stuff like this in here. You're probably going to want this to be, usually with while loops, you don't want to deal with actually changing the variable yourself, just because, unless, usually this is going to be like more of a Boolean kind of thing up here, not a Boolean from comparison, so it kind of depends on that. And then we'll sit on here and we'll output we're at 0. So this doesn't really make sense for encoders, but just kind of an example. So yeah, we'll run this. So it's just at 900. I was just a typo I made. I was paying attention, but obviously we're stopping when it gets to 900. And notice here that the code did run one last time because it checked. Are we greater than 900? We are. So this is at 901, subtracted more, and then we aren't, so we moved on down to here. So it's kind of that. So the last subject that I'm going to be talking about today is object-oriented programming. And this is just an introduction. I'm not going to really go too deep into this. There's a lot to learn about this kind of area of programming, but it's very useful to know about in FTC and really anywhere in Java. You're really going to have to understand this if you want to be using Java beyond this kind of simple abstract stuff that I've been showing. So object-oriented programming is a programming paradigm, and it's widely used in Java. It's kind of what Java was built off of. There are other programming paradigms such as functional programming, but if you feel free to learn about those if you desire. So this paradigm involves organizing code into objects, and the reason for this is that these objects can easily relate to real-world systems. And this particularly makes a lot of sense in robotics when we're most of the time working with real-world objects like motors or sensors or a robot as a whole, and it really makes things very easy to organize. It kind of makes a lot of sense, and it's very intuitive. And so just like the real world, this is kind of the model that's made with object-oriented programming. Objects have states, so variables and fields, and ways to change those states, or ways to interact with the object. These are methods that we've already learned about. And so this, and it's kind of like the classic example for object-oriented programming is a bike. So a bike has a lot of states or kind of properties about it. So it has a color, a model, and a brand, and these would be things like constant variables. They're not going to change. But it also has a current gear and a current speed, and stuff like that, in which you can change by pedaling the bike or using the gear shift. And these kind of actions would be like methods. And so kind of now bring this back to Java code. The center of this in Java is the class. So you might have saw on the IDE, at the top it said class main. A class can be thought of as templates for objects. In Java, every Java file you're going to make is probably going to be a class. When you create a class, you're setting up what every instance of that class, which is then an object, will have as its members. So for example, say if you're designing something to interface with a motor, you'll never be doing this, but say if you were, you want to have something so that when someone's using your code, they can easily declare a new motor and they don't have to be like rewriting the entire thing every time. It's a template. And so as a beginner, really the only class I'm probably going to be having you create yourself is going to be one that kind of organizes your robot as a whole and kind of holds all of its electronics, or perhaps a better way of doing this is organized by subsystem. That's what I personally use. And so each class will contain the electronics in that subsystem and methods to use those to kind of make your code make a little more sense of how things are organized. And classes also have the powerful tool of inheritance. So you can assign a parent class to a new class, and this new class will automatically inherit all the members of its parent. This sounds a bit confusing, but for example, say if you wanted to make a general class that represents a subsystem that has something like a list of motors inside of it, because every subsystem is probably going to have a list of motors. You can make that as its own class, and then now you want to make a specific subsystem. You can then make a class, for example, your drivetrain, and then what you do is you would say that this class should inherit from the subsequent class, so it gets the list of motors. And the reason this is so powerful and important is that it allows you to be able to be a lot more flexible in your code and to use objects that are of a broader kind of type, and it makes things like organizing things by list a lot easier, for example. And perhaps a more concrete example of this is when you're going to be making your first op mode. As I mentioned, this is the kind of program you're running on your robot. The op mode inherits from the complicated op mode parent class that the FTC devs made. And so this parent op mode class has all the complicated stuff of dealing with a ref expansion hub or a ref control hub, of managing event loops and all this complicated stuff that you'll never have to worry about because you just inherit from it, and you're overwriting. This means that you're taking part of the code and putting your own code into it. The two methods that are actually called to run your own code. So the init method, which is run when you press init, and the play method, which is run when you press play. Of course, I'm going to be talking all about this in next week's episode. And this is done with the extends keyword. So don't worry if what I've said so far about classes and object-oriented programming doesn't make complete sense right now. It'll become a lot more intuitive once you start writing real Java code, and you don't really have to know all the specifics to get started in FTC. I just want to kind of introduce this to you so you get a bit more of a concrete idea of what's happening when you jump into real FTC code. So I'm going to make a new file actually in Java. You're going to want to be organizing your things, your classes. Usually they each have their own file. And so let's say I'm going to make a template for, this actually will tie a bit into the homework. I'm not going to really go into that, the challenging homework. So let's say I want a class that represents an FTC team, so Java, and so I'm going to go up here and we call it, don't worry too much about the class, the public part. That's just an access modifier that determines who can access this class. Usually yours is going to be all public. I've never really had to deal with that. And so the syntax, you do class, you put the name. Of course, the name has to match the file name, just keep that in mind. Otherwise, things get mad at you. And so you have team. And so, as I mentioned before, a class or an object, which is when you instantiate this, has properties. So you go up here and say, for a team, of course, we're going to have a name. It's pretty straightforward. And you'll notice that I'm only declaring this variable. I'm not assigning it yet. And that's perfectly valid in Java. It'll probably be something you use quite a bit because you're going to want to assign a value to something after you start your program. So they have a name, and then just to make it simple, we'll make them have a number, which scores an integer. So we'll stick with that for right now. And so let's go back into main.java. As you see, this is a class. Don't really worry too much about that. I did delete the main method. All right, ignore that, and then so we're back here. And so you'll kind of see here, one thing about that class is that you'll see we have a class here. How you make an object, like an instance of the class, like I mentioned, there's a lot of teams that exist. Of course, that's just a template. So say and of course, as I mentioned, you can use any type. A class is a type that you can now use for your variable. So if I want to make a variable that stores, pixelated as a team, so team pixelated, and I see I've declared it here, but I'm going to want to assign it. How you make a new object is you use the keyword new, pretty straightforward. So new team, right? And so when you make a new thing, you have to be structured. You'll see here is that this runs fine, but it's pretty useless, right? I mean, what are we really trying to access here with the team? What we have to do is make a constructor. And so really what you do here is make the same name as the class, and this is kind of like a method, but it's called when you're making an instance of a class. And so I want to be passing in a string called name and then an int called number. And this is another weird thing. When you want to assign this, you have to use this. So this.name, that means that this name up here will equal the name you passed in. That's just kind of the order of the way things are kind of the scope here is that this one is the most local, so it'll be used when you just type in name. You have to specify this one as this dot name. Same thing for this dot number. And really, I'm not really expecting you to understand all this right now. This is kind of like a thorough example you'll have to use. And so now we've stored successfully in here. And you know what? Let's add another method, kind of like I mentioned before. We'll make this a void, and we'll call it print team info, right? And so this will be void, not returning anything. And all this will do is system. Well, we're going to print out. This is team. And so this is a cool thing here with strings. It's called concatenation. You can just use the addition operator and really add anything together. So the name, because it's stored. Oh, sorry, this is team. Put the number usually. And then you put comma here, and then the name. So let's see what else we've been using in our main class is being run. So now we have pixelated. You'll notice that we have to change this to actually meet this constructor. And so I had the name first, pixelated, and then the number. So 12835. What's cool here, you'll see here, is that since I had this team class, this team that all those things in it, like you'll do in classes for things like motors or things like that. So now I can do print team info, and then if I run this is team 12335 pixelated. So that's kind of a basic introduction to classes. Of course, I'm not able to really give you a comprehensive course on Java in this video. I just wanted to cover as much as I can. Hopefully you learned something new. If you have any questions, definitely feel free to reach out to us. And as I mentioned, for your homework, just mess around with Java in this online IDE that I showed you. You don't have to make an account even, you can just get started. And kind of a challenge project that I have for you, if you feel like you're pretty comfortable with Java already, or if you think that you grasp what I taught so far, is to make a scouting program that basically just asks the user for information about a team scoring ability. You can do this here, you can make up a game, it doesn't really matter, and stores this in an instance of a team. So you're going to make a class and probably add more variables and methods to then to be retrieved and viewed later. And this will be pretty difficult if you don't have experience in Java. As I mentioned, you're going to have to know how to do things with a list. I kind of talked about this a bit here. And you're also going to need to know how to get user input, which is from something called a scanner. You have to look that up as well. But yeah, definitely if you have experience in Java, try this out. If you don't, just really just kind of get familiar with Java in the online IDE, learn things, and yeah, do not hesitate to reach out to me through our email in the description, and I'll see you all next week.